All right, let's get things started. Hi, everyone. Welcome, and thank you for finding the time to join me today for our monthly webinar. My name is Annie Pettit, and I am the Chief Research Officer at Peanut Labs, a company that specializes in self-serve and full-serve research samples, as well as survey design. You can always find our full listing of webinars on the Peanut Labs website under the resources menu, and we will be recording this webinar, so if you need to leave early, we've got you covered. Now today I would like to welcome two special guests. Kelly Peters is the CEO and co-founder of BE Works, which is a firm that applies behavioral economics to real-world challenges. You can follow Kelly on Twitter with the username KellyBEWorks. Also joining us today is Supriya Syal, who is VP Research and Innovation at BE Works. And I will let them introduce themselves in just a minute. So in today's webinar, Kelly and Supriya will talk about behavioral economics in terms of some insights that make the scientific method more accessible for business and policy challenges. If you have any questions along the way, do feel free to type them into the question box at the side of your screen, and we will get to as many of those as we can at the end of the webinar. So now I would like to pass the computer controls over to Kelly and Supriya.
Hi everyone. Thanks very much Annie and Peanut Labs for sponsoring this talk. We're very excited to talk about behavioral science and its application in the real world. And in particular, we're very excited to talk about our take on a quote by the epic Steven Pinker. So I guess first what we wanted to do was just introduce BE Works and what we're all about. And there's a deeper look at my bio, which is basically a hybrid of business and strategy and innovation expertise with behavioral science expertise. And I'm dedicated to the fusion of those two ways of thinking and bringing science to life in the real world. My colleague Supriya Syal.
I'm a scientist who decided that I wanted to make real changes in the real world, and for close to 4 years now have been pursuing that dream with BE Works.
Awesome. So I just want to talk a little bit about the mission that we have for BE Works. So Supriya, myself, our co-founders, and our team very much believe that we're a purpose-driven company. We believe in the application of both the insights of behavioral science, so that domain knowledge of what we know to be true about how people make decisions and what influences their behavior in the real world, as the first part. And the second part is the application of the methods of science to how we both apply those insights, but how we further those insights, how we advance those insights in the real world. So that's the thing that motivates our team to have such passion for the work that we do on the application of behavioral science. Our team was founded in 2010, and I think one of the things that Supriya had said, you should talk about how we're a collective of scientists, and this team believes very much in science, comes from an interdisciplinary background, predominantly in the disciplines of psychology, and work to apply scientific language and thinking inside organizations. And so that's the cause that we're trying to advance.
Right. So we thought we'd jump in at the very outset and give you an example of the type of work that we do, just so you can contextualize where we're coming from. So I want to give you an example of an experiment that we did. We generated some insights which we think are very relevant to the real world. So this is an experiment on investor risk appetite. Let me unpack that for you a little bit. So if you go into a bank for the first time, a financial advisor at the bank will conduct what is called a risk assessment to measure your risk appetite before giving you any products or advice. So your risk appetite is basically a measure of how much risk you can tolerate in your investments. And since you're at the bank, meeting with a financial advisor, what is mandated by securities regulators in many countries across the world is that before offering any advice, the bank conducts this sort of risk assessment. And the idea in doing this is that by measuring your risk appetite, the advisor will subsequently be able to offer advice that is suited to this measured level of risk. But the thing to keep in mind, of course, is that the success of this policy is based on the assumption that the forms that these advisors use to measure risk appetite actually and accurately measure stable risk tolerance. From behavioral science, on the other hand, we know that people's decisions are fundamentally altered by the environment that they are made in. So as behavioral scientists, when we were studying this phenomena, this sort of policy regulation, we hypothesized that just as choices in the domains of something like consumer products, goods, can be swayed by the presence of, say, decoy products, investor risk tolerance would also be affected similarly by contextual or framing information. So how you ask the question might change the response. And this is what our research examined. It looked at how investor risk appetite is measured. Currently, we're based in Canada, so we looked at most major banks in Canada. And what we showed, somewhat alarmingly, was that they don't actually measure stable risk appetite. Instead, the investors were susceptible to both framing and context effects. So how you display the options changed the reported risk appetite. So what we were able to glean is that these forms don't actually measure stable risk appetite. The risk appetite is instead malleable to the framing and the policy that has been put in place in nations such as Canada and the US neither helps the consumer nor protects the advisor. So the reason I gave you this example is that what we're trying to illustrate here is that this is sort of our process. So this would qualify as what we step one of our process, and elucidation of the problem, or what we might call a descriptive step. Step two of our process would be more prescriptive. So now that we have laid out what the problem is, how can we come up with a solution? So what we're doing in this specific instance is that now we are in conversation with the Ontario Securities Commission to help build risk appetite forms and policies that actually help investors make better decisions, which is overall, I think, the process that we follow at BEworks. So we start out with scientific hypotheses. We find data for them in the real world, and then using that data, come up with a series of recommended interventions using which we can help make our process or a behavior better in the world, as it were.
Yeah, I think that this is probably a good time to now segue over to the Steven Pinker quote that we based this talk on, and we had a lot of fun as we sort of took apart this particular sentence and what it meant for our practice, and which aspects of it resonated with our experience and what were the ways that it didn't. And just kind of stepping back, I mean, I had read this sentence from his book, How the Mind Works, several years ago. It was when BEworks was new. We were finding our way between simply giving clients advice from what we knew from the literature, or on the other end of the spectrum, sort of the much harder job of giving our clients good science. And I think that when you talk about the project that we had with the investor risk appetite, there was quite a lot of effort that went into the development of those hypotheses and the development of the tests. And that's exactly what Steven Pinker would say. He would say good science is pedantic, expensive, and subversive. So I guess what we want to do is just go ahead and start to talk about this thing. So how it is that good science is each of those things. Well, first, why don't we talk about what we think good science is?
Right. I think that what is most important in order to say, what is good science is to first define how and why the science is being used. So at the very outset, we might say, well, science is being used as a systematic approach to solve problems. But I think that is followed immediately by two other things we need to consider. Number one is, what is your end goal? Is it to elucidate a scientific phenomena or a mechanism, or is it to change something in the world? If you're trying to change something in the world, as most businesses are, the first part of making it good applied science is, I think, defining success as clearly as possible. And number two of what is good science is to think about, is science being contemplated as a body of knowledge or as a method for generating solutions? So while the very act of using the scientific method to generate solutions obviously adds to the body of scientific knowledge, I think in many ways it is in fact the ideal and sort of the correct application of the scientific method that businesses struggle with. And that is where we are able to help them by building a culture of scientific inquiry and innovation through the scientific method.
Yeah, but it's not all easy. So if we start with this notion of science being pedantic, we wanted to first level the playing field with a good definition of pedantic in this context.
Yeah, so I think that in the purest sense, to be pedantic is to limit your reasoning to the premise that is mentioned in the question. So limit your attention to the details that have been provided. So to be pedantic is to ignore everything else we know when trying to find a solution to a given problem. So on the one hand, and that is what we need to do as scientists in the real world. We need to home in on the minutiae, the extreme details of a given problem, and eliminate any external factors so that we can understand true relationships or understand the ways of finding solutions to a given problem that can be applied across contexts at the client's office. And to do this, we go through a host of different tactics, some of which, of course, are how we structure our experiments, the rigor with which we adhere to the scientific method, how we focus on collecting our samples and make sure that they are representative of the populations that we are studying, how we ensure that we are measuring the right things, that even our measures have been pre-tested, and how much time we spend developing a theory or the hypotheses or the predictions, and even creating the models before we actually put our hypotheses to the test. So on the one hand, I would say science is pedantic because we try our best to limit our attention and our reasoning to the premise at hand, such that we are really homing in on what we are studying and making that relevant to the problem we are trying to solve for.
Yeah, and that supports behavioral economics in particular. I mean, behavioral economics is all about the very significant impacts that sometimes very, very subtle factors can have on people's both judgment and decision making. So in that way, pedantic is actually a very good thing, and it's very consistent with what we need to understand, the way we need to explore the process of behavioral economics insights in the real world. So that part works for us.
And at the same time, I say where we might diverge with thinker is that our science happens in the real world. It is, it's important to be pedantic in the context of learning how to do basic science, and being pedantic is important because it teaches us how to use a method without interference from external or confounding factors. But in the context of applied research and innovation, businesses or real actors are seldom interested in isolating a content-free algorithm or even say a pure relationship between X and Y. What they are instead most interested in is knowing how can we bring about Y in the world. And they're very interested in what other knowledge we can bring to the table from prior work we have done or other experiments in the world or predictions based in big data. So to speak, they are interested in what color we can add to the solution that actually lies outside the premise that is being mentioned in the question. And this is where I think the end goal comes in. Because since the end goal is driving behaviors in the real world, all of the tools and knowledge that we have at hand, even if they are outside the premise of the problem itself, become relevant and can generate insights.
Yeah, and this is also an interesting point for us, is that you're talking about how at the end of the day what we care about is driving results. But there's another thing that we talk about all the time, which is how we're also driving science. That we can study these fundamental principles about behavioral science, about human behavior, about judgment and decision making in the real world. We can make those so-called basic science insights from our work in the field, and it's going beyond the controlled lab-based research. And we would say that behavioral science itself is very, very interesting as a frontier where the legitimacy of field research can be as powerful as controlled research in the lab. And I'd like to be bold here, kind of on our behalf, if not more so. For example, in our work in the energy sector, we've applied a number of nudges to influence conservation behavior and energy utilization behavior. And to your earlier point, our field experiment can't possibly control for all of the factors in the real world. And yet the insights that we've generated on how these nudges work both independently and how these nudges work together can provide very useful insights to other behavioral science researchers operating back in the so-called controlled lab environment. So it's very much a two-way street. And a well-designed study, back to your point about leveraging the practice of controllable factors, and a well-designed study lets us elucidate those fundamental insights in our field research as well.
Absolutely.
So, okay, well that's great. So science is awesome, but science is expensive. Well, that's what our clients sometimes tell us is science is expensive. And so, yeah, it is. It's hard to do. Granted, we work really hard at designing experiments that, make sense from an ROI perspective. We work within, the constraints that are presented to us, and we work very hard at being creative and as creative as possible within those constraints. So we might get to the point where the actual experiment itself can be inexpensive, but the talent and the expertise to practice science isn't necessarily an inexpensive process. So here's where I'm going to say, Pinker, you're right.
I think Kelly, as the CEO of a firm that has hired many scientists, can probably vouch for how it's not actually inexpensive to have us around. But yeah, to the point that she was making, I think most definitely, good science requires rigor. It requires the right kind of equipment. It requires the usage of all the different methods that we have at hand that you might triangulate inferences from. And those are expensive. For instance, we ourselves have been branching out into a number of different methodologies outside of just behavioral research, such as eye tracking, and there's a number of other firms or other real-world research that is, using methods beyond the simply behavioral testing, and those methods are most definitely expensive. but they bring insights that are not just relevant, but more predictive of what is likely to happen in the real world. And I think, at least personally, that's what I think makes it worth it, that expense that one has to forego.
Well, and just kind of building on the fact that we use sometimes fairly intense methods. There's wonderful innovation that we're bringing into our practice. There are new technologies in terms of gathering observations in the world. Things like our work in call centers where we're using speech to text technology, but more advanced ways are facilitating translation of those text occurrences into natural language queries where we're able to measure sentiment of large amounts of spoken word into analyzable data. And so this is where technology and the frontier of technology supports the ability of scientific research to have better, more objective insights to formulate our hypotheses on. And then there's just other really cool stuff. There was a really neat study that was done in the US where consumers were asked to use their smartphones to take pictures of how they used a particular product. And they were able to get thousands of participants in this study that greatly surpassed a lot of traditional ethnographic participant sizes. And this research allowed us to gather a significant number of observations that can then in turn be used in a way that traditional methods just wouldn't give us that scale. But it's worth it. It's worth it to build these infrastructures for the technology to gather the observations. It's worth it to build the infrastructure to facilitate A/B testing and to have a company that's data-driven and evidence-driven, because we've talked about how important it is for strategy to leverage scientific insights, and this is where that convergence happens. This helps companies to take risks that they wouldn't otherwise be in the position to support, because they would only have intuition or maybe at best some previous experience or observations of a competitor's experience by which to support their business case. Experimentation allows you to take a potential area of opportunity and to break it down into its smallest components and to be able to evaluate whether or not there will be success with this particular idea in the market, whether there might be unintended consequences or other secondary effects. And so experimentation becomes incredibly useful for business strategy, both to mitigate any risks as well as to mitigate the risk of not trying in absence of being able to support that business case with evidence generated from an empirically driven process.
And when you compare the expense of trying a nifty little experiment against the potential cost of failure for not having experimented at all, I'd say the cost of experimentation becomes very small in comparison.
Yeah. All right. Here's our favorite point, though. We're going to go to the science is subversive. I guess for me, the thing is that we are challenging the hippos in the world with science. The hippo, the highest paid opinion in the room, because science, when we've generated the results at the end of the experiment and we're assessing sort of how did things go, it becomes quite fascinating to see how either the experimental conditions did vis-a-vis the baseline or the control, and often we see the results are they outperform the control. And it's interesting that independent of who generated the insights on what things to try, it doesn't matter if you are an alleged expert or an alleged authority or you had a strong intuition. At the end of the process, the experiments are able to reveal what was the right idea. It wasn't any force majeure that insisted on a particular idea. It was the result of the experiment itself that lends the authority, that lends the evidence to which idea is best. And I think for us, it's wonderful to democratize innovation inside an organization with the power of science. And so it lets us challenge that opinion, challenge previous assumptions, and the business term sort of sacred cows that are held close to one's heart with the results of these experiments. And I guess the other thing that makes good science very subversive is that it forces our biases to be on display, because the process of science has rigorous sort of documentation all the way through it, and that documentation, that peer review, those processes challenge what we know to be true, and allow us to potentially see in a more transparent way how those biases might have influenced our previous decisions.
Yeah. And then the one way I would actually say science is not all that subversive is that one of the central ideas that I'd say science is committed to is the idea that the world is intelligible, that it is explicable, even if slowly, by general phenomena. What that means is that we might not understand everything about a given idea or a given domain right now, but ultimately, through the progress of science, we will. But this also means that with time, science becomes less subversive. So let's take an example. 400 years ago, for instance, we understood very little about the brain. We didn't understand, we had a very limited conceptualization of how it is that the human brain works. And philosophers at the time believed that the only thing that makes us moral is the fear of God. That's what makes us act in ways that are moral. Today, lots and lots of experiments have shown that even small infants will show moral behavior well before they have any concept of fear or God or religion. So for us to now suggest that moral behavior evolved over time in humans is no longer subversive, because we're no longer trying to overthrow an idea. In this case, we're no longer trying to overthrow the idea that it is only the fear of God that makes us want to share with others or be fair to others. We're building now on what we already know from science, which is that evolution is true, rather than subverting some sort of long-held but flawed belief. And if you think of science as a way of approaching problems, a method rather than an end, this trajectory also applies to businesses. So the very first time a marketing department contemplates a randomized controlled trial that might provide data to question a long-held strategy, that might be subversive. But subsequent experiments they carry out won't be. They will simply be assuming that the world is intelligible and build on what has already been learned at that very same firm using the scientific method.
So that concludes our talk today. I just want to thank you again, Annie and Peanut Labs and the team for the invitation. If you have more questions about behavioral science and how it can be applied to real-world challenges, please get in touch.
Great. We are at the end of our time, and I do want to say thank you so much to Kelly and Supriya for taking the time to talk with us today. Do feel free to email or link or tweet with Kelly or Supriya or myself. We'd be happy to answer any questions you might have. So to everyone else, have a great day, and may you have as much fun with your data as Kelly and Supriya do. Bye, everyone.
Bye.